pages, or the status page, or the cruise page. The center part displays permanent data, and the lower part displays the ATC mailbox. Displays synoptic diagrams of the aircraft systems, for example, the wheel and flight controls pages. When a gray, More label appears next to the system page title, for example, Wheel More, it indicates that a More page is available. Fuel system pages have a More page.
Only the wheel and fuel system pages have a More page.
When it exists, the More page appears as soon as the More push button is pressed on the ECP. In such a case, a white underlined More label appears next to the system page title, for example, Wheel More. This page then provides additional information about the system parameters. Two amber crosses can appear when there is an invalid status or an information not available for the system. The cruise page provides basic information about fuel and air. It is automatically displayed when the aircraft is airborne and after passing 1,500 feet above aerodrome level or 2 minutes after liftoff. The fuel information includes the current fuel flow per engine, the fuel used per engine, and the total fuel used for all engines, and the APU. Note, in some cases, the fuel used total label is replaced by the fuel used all engines label. Refer to A380 Fuel Chapter. The air information includes all information associated with the cabin pressure system and the temperatures for each deck zone, each cargo zone, and cockpit. The status page provides an operational summary of the aircraft status. This page displays, from top to bottom, a deferred prox indication when applicable, a limitations indication when applicable, an info part to inform of any degraded aircraft system, and a NOPSIS list, and a More label to indicate that a More page is available. The status page automatically appears during approach, if not empty, when either the slats are extended or a barometric pressure altitude is selected. QNH, or automatically appears when the flight crew clears or cancels the last alert displayed on the engine warning display, or can be manually displayed at any time. In such case, the normal indication appears if there is no status information to display. The screen size does not permit the display of all information. A helpline, press status for next status page, appears at the bottom of the page to indicate the overflow state below. An amber, status not avail, indication appears when the SD can no longer display the status page. The CDS displays this message in case of communication failure between the flight warning system and the SD. When available, the More page, status More, is displayed as soon as the More push button is pressed on the eCam control panel. This page can display information about a system redundancy loss, indicate the alerts associated with performance, list any alerts that have been cancelled, and provide additional information to a procedure. When the screen size does not permit the display of all lines on the More page, a helpline, press More for Next More page, appears at the bottom of the page to indicate the overflow state below. The permanent data part of the SD is divided into three columns. The left column displays the external air temperature values. These values include the total air temperature, TAT, the static air temperature, SAT, and the International Standard Atmosphere, ISA, deviation. Note, the CDS uses the static air temperature value to compute the ISA deviation. The delta ISA is only displayed in standard borrow reference mode. The middle column displays the G-load value on the first line when the measured G-load exceeds a specific range. The Universal Time Coordinated UTC on the second line, and the specific message display system versions disagree when the CDS detects an inconsistency of version between each display unit. The right column displays the gross weight GW, gross weight center of gravity GWCG, and fuel on board FOB. The upper part of the PFD displays all the normal primary flight information: attitude, airspeed, altitude, vertical speed, and heading. Notice that these indicators are laid out in a conventional instrument T configuration. The upper part of the display provides also information on the flight guidance, FG. This area is known as the Flight Mode Annunciator, FMA. You will learn more about the FMA in the Auto Flight chapter. For additional information, refer to A380 Auto Flight chapter. In this module, we will concentrate mainly on the primary flight indications. The attitude information is shown in the center of the display. The reference position of the aircraft is represented by three yellow shapes filled in black that remain fixed. A graduated scale indicates the pitch angle of the aircraft below and above the horizon line. The scale has markers every 2.5 degrees between 10 degrees nose down and 30 degrees nose up, and for the minus 15 degrees, minus 20 degrees, minus 30 degrees, plus or minus 50 degrees, and plus or minus 80 degrees. Small green dashes indicate the pitch angle protection limit for the 15 degrees nose down and 30 degrees nose up. For additional information, refer to A380 Flight Controls Chapter.
A380 Flight Controls Chapter.
A radio height value is displayed when the aircraft is below 2,500 feet above ground level. For additional information, refer to A380 Navigation Chapter.
A380 Navigation Chapter.
An attitude pitch limit indication is displayed to avoid tail strike. At takeoff, from power setting to liftoff +3 seconds, and at landing, below 400 feet.
At landing, below 400 feet.
In flight, when the aircraft's pitch angle is too high, symbols appear to indicate an excessive pitch attitude and show the direction to reduce it. The bank angle of the aircraft is displayed at the top of the indicator. A fixed rule scale has a graduation for 10, 20, 30, and 45 degrees of bank.
20, 30, and 45 degrees of bank.
Small green dashes indicate the bank angle protection limit for plus or minus 67 degrees.
Protection limit for plus or minus 67 degrees.
The zero roll angle is indicated with a fixed yellow triangle. A roll index is indicated with a yellow triangle and moves against the fixed scale to show the value of the bank angle. A side slip index is represented by a trapezoidal shape below the roll index. It normally appears in yellow and indicates either the aircraft lateral acceleration on ground, or the aircraft side slip in flight. If one engine fails in depending on flaps setting and engine parameters, the side slip index appears in blue. It is then called the beta target. When the flight director, FD, push button is pressed on the Auto Flight System Control Panel, AFSCP, the pitch and roll bars are displayed on the attitude indicator. A yaw bar can also appear in specific conditions. For additional information, refer to A380 Auto Flight Chapter. Let's now have a look at the speed indications. The speed moves behind a fixed yellow reference line. This line indicates the current airspeed of the aircraft. The airspeed scale has markers every 10 knots and starts at 30 knots. A yellow speed trend arrow appears when the aircraft is accelerating or decelerating. This symbol indicates the airspeed that the aircraft will reach in 10 seconds if its current acceleration or deceleration remains constant. A target airspeed triangle appears either in blue when the target airspeed is selected by the flight crew, or in magenta when the target airspeed is managed, computed by the FMS. The target airspeed is presented with a digital value above or below the airspeed scale when the value is outside the airspeed scale. A blue V1 and a magenta V2 speeds are shown when they are manually entered in the active performance page of the MFD. These speeds are beyond the visible scale and are then presented in digital form. V1 and V2, which were beyond the visible scale, are now displayed. A blue circle appears to represent the VR speed. Note, V1 and VR indications disappear after liftoff. The airspeed indicator shows also a green F, referred to as F-speed, to indicate either the target speed during approach, or the minimum flap retraction speed during takeoff or go around. Two amber lines, referred to as VFE next, to indicate the next flap limiting speed when the aircraft is below 20,000 feet. A green S, referred to as S-speed, indicates either the target speed during approach, or the minimum slat retraction speed during takeoff or go around. When the aircraft is in conform plus F, the lower end of a green tape shows the value of the automatic retraction speed, ARS, for which the flaps will be automatically retracted. A short-term managed speed target may appear either as a magenta dot when the short-term speed value is displayed inside the speed scale, or as a magenta half dot when the short-term speed value is outside the speed scale. For additional information, refer to A380 Auto Flight Chapter. When the aircraft is in clean configuration, a green circle indicates the optimum speed to have the best lift over drag ratio. This speed is referred to as green dot speed. A Mach indication appears in green below the speed scale when the current speed goes above the equivalent of Mach 0.5. During a managed descent, the magenta triangle indicates the target airspeed and two double magenta lines show the acceptable speed variations to maintain the descent path. The lower end of a red and black strip shows the maximum allowed speed, Vmax. This speed is the lowest of the maximum operating speed in clean configuration, VMOMMO, the maximum flap extended speed, VFE, and the maximum landing gear extended speed, VLE. There are indications associated with speed and angle of attack protections. The top of an amber tape indicates the lowest selectable speed, VLS. The top of an amber and black strip shows the alpha protection speed, referred to as the alpha pro, and the top of a red strip shows the alpha max speed, referred to as the alpha max. For additional information, refer to A380 Flight Controls Chapter. The top of a red and black strip shows the stall warning speed, referred to as VSW, in specific conditions. For additional information, refer to A380 Flight Controls Chapter. When the 3ADRs cannot provide the airspeed information anymore, the airspeed indication is replaced by a backup speed indication. For additional information, refer to A380 Navigation Chapter. Let's now have a look at the altitude indications. The altitude moves behind a fixed digital readout window, which indicates the current altitude of the aircraft. The altitude scale has markers every 100 feet. On the right side of the altitude scale, the top of a red ribbon shows the ground elevation. This symbol appears when the aircraft is below 570 feet radio altitude. The distance between the top of the red ribbon and the center of the altitude window represents the current radio altitude of the aircraft. The top of a brown ribbon indicates the landing elevation of the destination airport. When entered in the MFD performance page, the top of an amber ribbon indicates the minima in QNH or QFE reference. At the bottom of the altitude scale, a barometric reference setting is displayed according to the pressure reference, QNH, QFE, or standard, and the unit reference, hectopascal, HPA, or inches of mercury, in Hg. A blue box indicates either a target altitude or a target flight level in standard mode. When outside the altitude scale, the target altitude or flight level is indicated by a digital value above or below the altitude scale. When in managed vertical mode, the altitude constraint or flight level constraint is then presented in magenta. The selected and the current aircraft altitude appear in meter when the meter push button is pressed on the AFSCP. When the 380s cannot provide the altitude information anymore, the current altitude is provided by the GPS only, and the two last digits of the current altitude indication are dashed in amber. In such a case, a white GPS alt message appears below the altitude scale, and a white GPS message appears on the right side of the altitude scale. For additional information, refer to A380 Navigation Chapter. A green disk indicates the vertical deviation between the current altitude of the aircraft and the vertical descent path computed by the FMS. Let's now have a look at the vertical speed indications. The vertical speed scale ranges from -6,000 feet per minute to +6,000 feet per minute. A yellow reference line corresponds to a vertical speed of 0 feet per minute. The scale has markers every 500 feet between -2,000 feet per minute and +2,000 feet per minute, and every 2,000 feet per minute otherwise. A needle and its digital value move on the scale. They appear either In
Move on
green,
the
when the
scale.
vertical speed is below 6,000
In
feet per
green,
minute,
when the
or
vertical speed is
in
below
amber,
6,000
when the
feet
vertical
per
speed is
minute,
above this
or
value.
in amber,
When the vertical
when the
speed
vertical speed
value
is
is
above this
based on
value.
barometric
When the
data
vertical
only,
speed
from the
value is based on
ADRs, an
barometric
amber
data
window
only,
surrounds the
from the
digital value.
ADRs, an
Note,
amber window
the digital
surrounds the
indication
digital
appears
value.
only when the vertical
Note, the
speed is
digital
either above
indication
plus
appears only when
200
the
feet per
vertical
minute,
speed
or
is
below
either
minus
above
200
plus
feet per
200 feet
minute.
per minute, or below minus 200 feet per minute.
Let's now have a look at the heading indications.
Let's now have a look at the heading indications.
There's a direct relationship between the white vertical lines on the heading scale and the white vertical lines on the horizon line of the attitude indicator. Note, when a heading changes, the white vertical lines of the attitude indicator move to stay in line. A gray scale moves against a fixed yellow line that indicates the current heading of the aircraft. In this example, the current magnetic heading of the aircraft is 45 degrees. The heading scale has markers every 5 degrees. When true is selected, a blue true message appears above the heading reference line to indicate true heading. Green diamond indicates the current track of the aircraft. In this example, the current track is 50 degrees, which means that drift is 5 degrees. Selected heading or track appears either as a blue triangle when a heading value is inside the heading scale, or as a blue digital value on the appropriate side of the heading scale when a heading value is outside the scale. When the FD bars are set to off, a blue vertical line appears on the horizon line of the attitude indicator to indicate the selected heading or track. There's a direct relationship between the blue triangle on the heading scale and the blue vertical line on the horizon line of the attitude indicator. Note, when the selected heading changes, the blue vertical line of the attitude indicator moves to stay in line. Now, let's have a look on the landing system. LS information. The LS information can be either precision or non-precision approaches deviations. For an ILS, GLS approach, the information displayed are the glide slope deviation, the localizer deviation, the ILS GLS message, the ILS GLS course pointer, and the ILS GLS information identification, frequency, channel, and DME distance. The ILS GLS course is displayed on the heading scale and appears either as a magenta single dagger when the course is inside the heading scale, or as a magenta digital value on the appropriate side of the heading scale when the course value is outside the scale. A magenta diamond represents the glide slope index on the glide slope scale, and the localizer index on the localizer scale. A magenta half diamond is displayed when the glide slope and or localizer indexes are outside the displayed scale. For FMS landing system, FLS, non-precision approach, the information displayed are the pseudo-glide slope, F-glide slope, deviation, the pseudo-localizer, F-log, deviation, the FLS message, the FLS course pointer, and the FLS information, anchor point identification, slope, and distance.
Anchor point identification, slope, and distance.
FLS course is displayed on the heading scale and appears either as a magenta double dagger when the course is inside the heading scale, or as a magenta digital value on the appropriate side of the heading scale when the course value is outside the scale.
When the course value is outside the scale.
A magenta double diamond represents the F-glide slope index on the F-glide slope scale and the F-localizer index on the F-localizer scale. A magenta half double diamond is displayed when the F-glide slope and or F-localizer indexes are outside the displayed scale. A symbol indicates the lateral aircraft trajectory, track, and the vertical aircraft trajectory, flight path angle, with respect to the ground, taking into account the wind effect. This symbol is referred to as velocity vector, VV, and appears either in black when heading vertical speed is selected on the AF/SCP and the VV push button is pressed on the EFIS control panel, or in green when drag FPA is selected on the AF/SCP. When the FD push button is set to off, the size of the symbol increases. In this example, the velocity vector and the track diamond are in line with the current magnetic heading because there is no wind effect. The aircraft is flying with a pitch attitude of 5 degrees, and the VV indicates a descent with the flight path angle of -5 degrees. As a result of a wind from the right, the aircraft has now a 4-degree drift to the left. Let's now have a look at the lower part of the PFD. The lower part of the PFD displays slats, flaps, landing gear and spoilers indications, memos, limitations, and pitch trim indications on ground. For additional information on the slats, flaps, landing gear, spoilers and pitch trim displays, refer to A380 Flight Controls Chapter. Navigation display, ND, provides the flight crew with lateral navigation information of the aircraft according to the flight plan and the navigation database, waypoints, navaids, airports. The flight crew can also directly interact on some elements of the ND to modify the flight plan and display weather radar, terrain, traffic, collision avoidance, and airport navigation. For additional information, refer to ATA-34 Navigation Chapter. 5 ND modes can be selected by the mode selector on the
5
EFIS
ND
control
modes can be
panel.
selected by the
The
mode
plan
selector
mode
on the
displays
EFIS
the flight
control
plan on a
panel.
map,
The
with
plan mode
north,
displays the
south,
flight plan
west
on a
and
map,
east references.
with north, south, west and east references.
The arc mode displays a 100 degrees heading sector ahead of the aircraft.
100 degrees heading sector ahead of the aircraft.
The nav mode gives the same information as the arc mode, but on a 360 degrees sector.
But on a 360 degrees sector.
The VOR mode represents the horizontal situation of the aircraft with VOR course and deviation. The LS mode displays the localizer and glide slope indications. Let's now view some common information to all modes. The ground speed, GS, and the true airspeed, TAS, are permanently displayed in knots on the top left corner. The wind information that are presented below the speed indications are the wind direction with respect to true north and wind speed that are both indicated in a green digital form. The wind direction with respect to magnetic north that is indicated by a green arrow and appears when the speed is greater than 2 knots. Note, for training purposes, some information are now deemed in the following slides. The aircraft heading is indicated by a yellow fixed line against the moving compass rose. A yellow aircraft symbol presents the aircraft markup orientation in accordance with the aircraft heading. When a heading or track mode is selected on the auto flight system control panel, a selected heading or track indication appears, either as a cyan triangle, when the selected heading or track is inside the displayed scale, or as a cyan digital value, on the appropriate side of aux scale, when the selected heading or track is outside the displayed scale. The actual aircraft track is indicated with a green diamond. When the heading or track mode is selected on the AFSCP, a green track line indicates the predicted aircraft track based on the current aircraft track. A white azimuth line appears when the azimuth radar is manually selected on the surveillance panel. For additional information, refer to A380 navigation chapter. A magenta dagger indicates the QFU of the LS course on the heading scale when an approach is selected in the FMS. The dagger is either single for an ILS course or double for a FLS course. The range marks are indicated by white dashed lines, and the range values are displayed in blue. The display range can be adjusted by the range selector on the FS control panel. In each mode, for example, arc mode, each dashed arc and its range values correspond to a value of the selected range. A TCAS arc is also displayed when the selected range is below or equal to 20 nautical mile and the traffic push button is pressed on the FS control panel, or if a TCAS alert occurs. Now, let's have a look on the landing system. LS information. The LS information can be either precision or non-precision approaches deviations. For an ILS approach, the ILS mode provides standard localizer lock and standard glide slope G/S deviations. The ILS deviations include a single course pointer to indicate the selected course, a single deviation bar to indicate the aircraft deviation from the ILS course, and a single diamond to indicate the aircraft vertical deviation from the glide slope. The ILS station information displayed on the top right corner are the selected ILS station with a tuned frequency, the ILS course, the ILS identifier, and the manual tuning indication to remind that the nav aid is manually selected. The M indication appears if the nav aid is tuned via the multifunction display MFD, and the R indication appears if the nav aid is tuned via the radio management panel RMP. For FLS non-precision approach, FMS landing system, the FLS mode provides pseudo-localizer, F-lock, and pseudo-glide slope, F/G/S deviations. FLS deviations include a double course pointer to indicate the selected course, a double deviation bar to indicate the aircraft deviation from the FLS course, and a double diamond to indicate the aircraft vertical deviation from the F-glide slope. The FLS station information displayed on the top right corner are the selected FLS station with the slope value, the FLS course, and the FLS identifier. For Lock FLS non-precision approach, the Lock FLS mode provides localizer lock and pseudo-glide slope F/G/S deviations. The Lock FLS deviations include a single course pointer to indicate the selected course, a single deviation bar to indicate the aircraft deviation from the ILS course, a lock message to indicate that no back beam mode is selected, a double diamond to indicate the F-glide slope deviation, and a F-glide slope message to indicate that Lock FLS mode is selected in the FMS. The Lock FLS station information displayed on the top right corner are the selected Lock FLS station with the slope value, the Lock FLS course, and the Lock FLS identifier. The ROSE VOR mode is another Row data
The ROS
display.
VOR mode
This mode
is another
displays
row data
a
display.
VOR course pointer
This
to
mode
indicate the
displays
selected VOR
a VOR
course,
pointer
a
to
VOR
indicate the
deviation
selected
bar
VOR
to
course,
indicate the
a
aircraft
VOR
deviation from the
bar
selected
to
course,
indicate the
and
aircraft
a
deviation
VOR
from the
station
selected
information
course,
on the
and
top right corner
a VOR
to assist
station
the flight
information
crew.
on the top right
Note,
corner
the blue
to assist
VOR
the
course
flight
and
crew.
deviation are
Note,
only
the blue
visible
VOR
when they have
course and
been manually
deviation
inserted
are
in the
only
MFD
visible
nav aid
when they
page.
have been manually inserted in the MFD nav aid page.
A white VOR1 bearing pointer and the
A white
associated active
VOR1
navigation
bearing
station
pointer
are
and the
displayed when the
associated active
VOR1 is
navigation
selected on the
station are
EFIS
displayed
control
when the
panel.
VOR1 is selected on the EFIS control panel.
A white VOR2 bearing pointer and the
A white
associated active
VOR2
navigation
bearing
station
pointer
are
and the
also displayed
associated
as
active
soon as the
navigation
second
station are
VOR2 is
also
selected on the
displayed as
EFIS
soon as the
control
second
panel.
VOR2
The
is
bearing
selected on the
pointers
EFIS
and their
control
dedicated
panel.
active navigation
The bearing
station
pointers
are
and their
displayed in
dedicated active
LS,
navigation
VOR,
station
NAV,
are displayed
and
in LS,
ARC modes when
VOR,
one VOR
NAV,
and
ARC
or
modes
ADF
when
is
one
selected on the
VOR
EFIS
and
control
or
panel.
ADF is
Notice
selected on
also
the
that
EFIS
a white
control
underlined R
Notice
is
also
displayed to
that a
indicate
white
that the nav aid is tuned
R
via the
is
radio
displayed to
management
indicate that the
panel.
nav aid is tuned via the radio management panel.
The receiver 1 data, VOR1, or ADF1, is displayed on the left side of the ND, and the receiver 2 data, VOR2, or ADF2, is displayed on the right side.
ADF2 is displayed on the right side.
The ADF1 is now selected on the EFIS control panel. A green ADF1 bearing pointer replaces the white VOR1 bearing pointer, and the VOR1 information on the bottom left corner is replaced by the ADF1 information. Notice that a white underlined M is displayed to indicate that the nav aid is manually tuned via the MFD. The ADF2 is now selected on the EFIS control panel. A green ADF2 bearing pointer replaces the white VOR2 bearing pointer, and the VOR2 information on the bottom right corner is replaced by the ADF2 information. A flight plan information is only displayed in nav, ARC, or plan modes when the ND range is higher or equal to 10 nautical miles, for example nav mode. On the EFIS control panel, the range selector is set at 320 nautical miles, which is the distance from the bottom to the top of the compass rose. The green line represents the flight plan that you will view in more details in the auto flight modules. To give information on the to waypoint, the active waypoint information displayed on the top right corner are the identification and direct bearing to go, the direct distance to go, and the estimated time of arrival, ETA. In this example, the active waypoint is Sierra Tango Papa. Note, the ETA assumes that the aircraft directly flies from its present position to the active waypoint at the current ground speed. To give information on the to waypoint, the active waypoint information displayed on the top right corner are the identification and direct bearing to go, the direct distance to go, and the estimated time of arrival, ETA. In this example, the active waypoint is Sierra Tango Papa. Note, the ETA assumes that the aircraft directly flies from its present position to the active waypoint at the current ground speed. The flight crew can use the push buttons at the top of the EFIS control panel to display all navigation database on the MD. These elements can be displayed in nav, arc, or plan modes. When the ARPT push button is pressed, all the airports contained in the database appear within the display range. When the MDB push button is pressed, all the non-directional beacons contained in the database appear within the display range. When the VORD push button is pressed, all the VOR contained in the database appear within the display range. When the WPT push button is pressed, all the waypoints contained in the database appear within the display range. When the CSTR push button is pressed, the constraints related to the flight plan, speed, altitude, time appear within the display range. Let's now have a look at the interactive function of the MD. The flight crew can perform the following FMS tasks on the interactive MD. Direct to, insert a waypoint, insert next waypoint, and delete a waypoint, delete. The flight crew can also insert or erase a pending temporary flight plan, insert temporary or erase temporary, and select an airport for data consultation. Data. As the interactive ND is associated to the flight plan display, it is only accessible in nav, ARC, and plan modes. For additional information, refer to A380 Autoflight chapter. The vertical display, VD, is located at the lower part of the ND and provides a synthetic view of the vertical situation of the aircraft. For additional information, refer to ATA-22 and ATA-34. One or more display unit DU fails, there is a reorganization of the displays to provide the flight crew with the necessary information. This is called display unit reconfiguration. The reconfiguration can be either automatic or manual. The primary flight displays, PFDs, and the engine warning display, EWD, are considered as the most important for continuing the flight. They are normally and respectively displayed on the captain, first officer, PFD, and the engine warning display. When the PFD fails on the captain and/or first officer side, the PFD is automatically displayed on the MD of the same side. If the engine warning display fails, the engine warning display is automatically displayed on the SD. In case of display unit failure, The flight crew can manually reconfigure one of the remaining display units to recover the lost display. This manual reconfiguration is done using either the Reconf push button or the KCCU functional keys. As soon as a DU fails on one side, its on-side Reconf push button becomes active and allows the flight crew to reconfigure the corresponding PFD, ND, and or MFD. Here, only the captain Reconf push button is active. When the engine warning display and or the SD fails, the Reconf push button becomes active on both sides. The engine warning display and or the SD can be respectively displayed on the first officer ND and captain MFD. The engine warning display and the SD cannot be displayed on both sides at the same time. Flight crew uses its own Reconf push button to display the appropriate information. The failed DU can also be directly reconfigured to the appropriate DU by pressing the dedicated functional key of the on-side KCCU. For example, the flight plan key of the captain KCCU. The concentrator and multiplexer for video. CMV concentrates and multiplexes aircraft videos provided by different systems to display them on some display units, DUs. The CMV manages the following video source systems: external and taxiate camera system, ETACS, that can be displayed on both PFDs and or the SD. Onboard Airport Navigation System, OANS, that can be displayed on both NDs. Cabin Video Monitoring System, CVMS, and Cockpit Door Surveillance System, CDSS, that can be displayed on the SD. The display of the ETACS on the PFD and the display of the OANS on the MD can be activated from the FS control panel. The video source, CDSS, CVMS, or ETACS, that can be displayed on the SD is activated from the ECAM control panel. The ETACS gives an external view of the aircraft to the flight crew in order to make the taxi maneuver easier. Two cameras are used in the aircraft for external view from the cockpit: vertical stabilized radar camera, also called fin taxi aid camera, FTSC, and belly taxi aid camera, BTSC. The video received through these cameras can be displayed either on the captain and or first officer PFD when the aircraft is on ground and the on-side taxi push button is pressed on the FS control panel below 60 knots, or on the SD in flight when the ETACS source is selected from the ECAM control panel. The videos are displayed as follows. The video from the belly taxi aid camera appears on the upper part. Two magenta squares appear, and each one represents a 5-meter distance from the nose landing gear. The video from the fin taxi aid camera appears on the lower part. Two magenta lines appear, and each one materializes an outer edge of the main landing gear. The onboard airport navigation system, OANS allows the flight crew to display an airport map called Airport Nav when the range selector of Captain and or First Officer FS control panel is set to zoom. The airport nav is displayed on the related ND.
The airport nav is displayed on the related ND.
For additional information, refer to A380 Airport Nav Chapter.
A380 Airport Nav Chapter.
The Cabin Video Monitoring System (CVMS) displays a video on the SD when the flight crew presses the video push button and selects the CVMS source through the video knob. The Cabin Video Monitoring System is designed to help the flight and cabin crew to observe hidden areas and detect unruly passengers, suspicious behaviors, or other potential threats. The Cockpit Door Surveillance System (CDSS) is displayed when the flight crew presses the video push button and selects the CDSS source through the video knob. The Cockpit Door Surveillance System (CDSS) is displayed on the SD and is designed to help the flight crew to identify a person requesting to enter in the cockpit and survey the hidden cross-section between the right and the left-hand door. Flight recorders are composed of two systems: the Cockpit Voice Recorder System (CVRS) and the Digital Flight Data Recorder (DFDR). The Cockpit Voice Recorder System records both onboard audio and data link communications. It is mainly composed of a Cockpit Voice Recorder control panel, a cockpit area microphone, and a solid-state cockpit voice recorder (SSCVR). The SSCVR stores at least the last 2 hours of mandatory audio cockpit and data link messages. It stores data in a crash-protected memory, and an underwater locator is attached to this SSCVR. The Digital Flight Data Recorder (DFDR) stores the last 25 hours of all mandatory parameters in a fire and shock-proof box, which also has an underwater locator beacon. On the pedestal, a DFDR event push button can also be used to set an event mark on the DFDR records. The flight recorders operate automatically in flight, whether the engines are operative or not, and on ground, during the 5 minutes after the aircraft electrical network is energized or as soon as the first engine is started, and until 5 minutes after the last engine is shut down. The flight crew can use the ground control push button on the RCDR panel to manually start the recorder. Note, it is not possible to stop the recorder in flight. When the ground control push button is pressed on ground, the on light comes on to inform that recorders are manually activated. It will automatically extinguish as soon as the first engine is started.